Welcome back to the deep dive. Today, we're jumping into the climate crisis,
Yeah.
but maybe from a different angle than usual. Not policy, not protests. We're looking at something fast, technical, artificial intelligence. We've got this really interesting piece from CBS News to guide us. It focuses on a company that's right at the intersection of climate action and AI.
Yeah, and I think our mission today is to kind of wrestle with the core tension that CBS highlights. I mean, we obviously need powerful solutions like yesterday, but we also have to be really careful that the solutions themselves don't end up adding to the problem.
Exactly. So the big question for you listening, the one we're trying to unpack, is basically, how can AI actually fight the climate crisis without, making it worse through its own energy demands? It's a tough one, a real balancing act.
And to dig into that, we're going to look at this company mentioned in the report, ClimateAI. They're actually a great case study for both the potential and, yeah, the pitfalls here.
Okay, Climate AI. Let's talk about them. The report mentions the CEO, Himanshu Gupta, and it stresses that they're focused on applied AI. So this isn't just theory, right? This is AI being put to work now.
Right. It's about taking AI out of the lab and using it for, well, real business decisions today. And what's really interesting is how they're applying it. Most people hear climate action and think, okay, cutting emissions, mitigation. But climate AI, they're heavily focused on adaptation.
Adaptation.
Yeah.
Okay. So dealing with the climate change effects that are already baked in.
Exactly. It's about building resilience because let's face it, some changes are already happening or are unavoidable now. Think of it like this maybe. Mitigation is hitting the brakes to avoid a car crash. Adaptation is fitting better airbags because you know the crash is coming anyway. Climate AI is helping businesses build systems that can, cope and even function as the climate gets more unpredictable.
That makes a lot of sense. We can't just undo everything overnight.
Yeah.
So why is adaptation just as vital as prevention, especially for these big industries?
Well, honestly, it's pragmatic. If you don't adapt, things break badly. Imagine a huge food company that can't deal with new drought patterns. They don't just lose profit. Global food supplies get disrupted. That causes huge instability, right? So Climate AI provides these super detailed long-range forecasts that gives businesses the foresight to manage risk, to keep essential systems running even when things get rough.
Okay, and the source material, the CBS piece, it really narrows down where climate AI is focusing this predictive power. It specifically calls out food and water supply chains, helping businesses adapt those. And when you think about it, food and water, that's fundamental. And they are incredibly sensitive to climate shifts. Think about farming, water availability. It all relies on predictable weather, which we just don't have anymore. A flood here, a drought there. It can mess up the whole global system almost overnight. So yeah, perfect candidates for AI. The complexity is just huge.
Absolutely. And it's the scale that really demands AI. Let's picture it. Say you're a big drinks company, you operate globally. You need reliable clean water from, I don't know, maybe 10 different places across multiple continents. Okay, so Climate AI's models might crunch decades of climate data, ocean currents, soil moisture, jet stream forecasts, all of it. And maybe they predict a, say, 40% drop in water reservoir levels in a key region, maybe the Midwest US, but 5 years from now. A human analyst might see a short-term trend, sure, but the AI can see that bigger, longer-term picture.
Wow, 5 years out.
Yeah. And that lets the drinks company act before the crisis hits. They can secure other water sources, maybe invest in water treatment tech, or even plan to move production all years ahead of time.
That's a powerful example. It's taking all this complex environmental data and turning it into something a business can actually use. So it's not just waiting for the disaster. It's modeling maybe 50 possible futures and finding the best route through.
Pretty much. And the speed is crucial, too. Trying to track global food and water risks manually. It's like playing 10 chess games at once, blindfolded. A person might see a few moves ahead on one board. The AI sees the whole setup across all boards, factoring in all the complex interactions, maybe 30 years into the future. It allows for proactive steps that old-school forecasting just couldn't manage.
Incredible capability.
Wait.
But here's the bit. This brings us right back to that difficult question the source raised. We see AI as this potential adaptation hero. But we have to ask, how can artificial intelligence combat the climate crisis without contributing to it?
And this is the tricky part, the kind of inherent contradiction. We know these AI models, especially the big, complex ones needed for global climate prediction, they need enormous amounts of computing power.
Mhm.
Just training these things means running massive data centers, often for days or weeks. That burns a lot of energy. I mean, some studies have shown, and this is maybe at the extreme end, for really large language models, that training just one model can potentially emit as much carbon as several cars over their entire lifespan. It really depends on where that electricity comes from, of
This
course.
is quite a trade-off. So we're spending carbon now, running these computers, hoping to build resilience for later, using energy, often from fossil fuels, to power the data centers,
Hmm.
to solve the problem caused by fossil fuels. That's the loop we're in.
It's the ultimate balancing act, yeah. And it makes you ask, well, how do we even know if it's worth it? Is the overall impact positive? It's not a simple calculation.
Wait, yeah, let's talk about that calculation. How do you figure it out? If AI helps a company optimize shipping and cuts, say, thousands of tons of CO2, that's good. But if training that AI happened in a data center running on coal, how do you weigh the benefit against the initial carbon cost?
It's super complex, and honestly, it's an area where greenwashing could easily happen if companies aren't totally transparent. You'd need to account for everything.
Mm-hmm.
The carbon cost of making the computer chips, the energy used for training the model, the energy for running the model day to day, and then weigh all that against the predicted climate benefit, the water saved, the food waste reduced, the emissions avoided.
So the bottom line has to be that the climate benefits from the AI saved water, efficient supply chains, whatever they have, to clearly outweigh the carbon cost of the AI itself, like significantly.
Absolutely. It has to be a clear net positive. If you
Oh.
develop an AI using dirty energy and it uses tons of power just to achieve a tiny bit of resource saving,
Hmm.
well, then the tech is actually part of the problem, isn't it? So the focus really has to shift and is shifting towards energy efficient AI.
Which puts a huge responsibility on companies like ClimateAI, right? They don't just need smart algorithms, they need super efficient operations. They need to optimize how they train models, maybe make the model smaller if possible, and crucially, use computing infrastructure powered by clean, renewable energy. Making sure the solution isn't part of the problem is basically essential for them now.
Totally. The game has changed. It's not enough for AI to be clever anymore. It also has to be provably green. And this push for energy efficiency, it's driving innovation across computer science, not just in climate tech.
Okay, so let's quickly recap for you, the listener, what we've explored today, drawing from that CBS source. We looked at climate AI under Himanshu Gupta using applied AI, specifically helping businesses adapt those critical, complex food and water supply chains to the realities of climate change.
And maybe the bigger takeaway is that this whole area forces us to face that challenge head on. AI's own environmental impact. It highlights why energy efficiency and, frankly, honesty about that energy use are absolutely crucial for any climate tech. The potential is huge, but so is the energy question. So, maybe here's something to think about after this. If AI's power to fight climate change really hinges on how efficiently the computers run the data centers, the chips, and how clean the electricity is that powers them, does that mean the future of climate adaptation depends just as much on breakthroughs in computer hardware and clean energy as it does on the AI software itself?
That's a really interesting point. It connects everything together. It means the climate fight involves not just coders, but electrical engineers, material scientists, energy grid operators, everyone. Okay, fascinating stuff. Thanks for diving in with us today. We'll catch you next time.